September 15th, 2017. NASA's Jet Propulsion Laboratory in California. A silence hung over the control room, thick enough to cut with a knife. Hundreds of engineers who had dedicated half their lives to this project were staring at a single monitor. On it, a green radio wave pulsed rhythmically. It was the heartbeat of a robot located 1.5 billion kilometers away. At 4:55:39 a.m., the wave faltered. Then, it flattened into a thin, straight line, the hiss of static. And then, nothing. Flight Director Earl Mays took off his glasses, leaned into the microphone, and spoke the phrase he had been preparing for 20 years. "The signal has been lost. The spacecraft has burned up. This is the end of the mission." People in the hall began to applaud, but tears were streaming down many faces. They had just killed their greatest creation. But here is the most chilling part of this scene. At the exact moment the signal vanished from the screens in California, the Cassini probe itself had long ceased to exist. Radio waves take 83 minutes to travel from Saturn to Earth. When the engineers were drinking their morning coffee, bracing for the finale, Cassini was already dead. It had burned up in the gas giant's atmosphere an hour ago. We were simply listening to the echo of a ghost. Let's rewind time by 83 minutes, back to where it was actually happening. Imagine you are suspended above the clouds of Saturn. Below you lies an infinite ocean of gold and beige gas. Your falling speed is 113,000 kilometers per hour. That is 30 times faster than a bullet. Cassini entered the upper atmosphere like a meteor. The temperature of the hull instantly spiked to thousands of degrees. Aluminum began to melt and stream backward like tears. But the onboard computer kept fighting. Its task was impossible: keep the antenna pointed strictly at Earth while turbulence tossed the 2-ton apparatus around like a paper plane in a hurricane. The attitude control thrusters were firing at their limit, blasting jets of gas every millisecond. The probe screamed data at us until its very last breath. It tasted the atmosphere. It measured the magnetic field. It transmitted information for which it sacrificed its life. And then, the atmosphere won. The antenna shifted a fraction of a degree. The connection was severed. Seconds later, the structure disintegrated, and Cassini became part of the very planet it had studied for 13 years. Why did we do this? Why steer a fully functional working spacecraft worth $3 billion to a certain death? Why couldn't we just leave it in orbit? The answer to this question is frightening in its simplicity. We killed Cassini because it found something we didn't expect. It found places where life might exist, and if the probe, which might still have had Earth bacteria on its chassis, were to accidentally crash into one of these moons, we would contaminate an alien world. We would become the aliens bringing the plague. To save potential life down there, we had to destroy the only eyes we had up there. But before it burned, Cassini managed to send us terabytes of images and data. It showed us the rings from angles no one had ever seen. It flew through the geysers of icy moons. It saw rains of methane. And what it showed us completely changed our understanding of the solar system. Saturn turned out to be not just a beautiful planet with a hoop. It is a crime scene. It is a giant gravitational meat grinder that pulverizes worlds, creating its famous ornaments from their remains. To understand exactly what Cassini saw in its final moments, we need to go back to the beginning, to the moment when a human first pointed a tube with lenses at the night sky and couldn't believe his eyes. July 1610. Galileo Galilei points his homemade telescope at the farthest known planet of the time. What he saw forced him to wipe his lenses, then wipe his eyes, and look into the eyepiece again. Saturn was not alone. Galileo saw a large sphere in the middle and 2 small spheres on the sides, almost touching the central one. He wrote in his diary that Saturn is a triple planet. He thought he was seeing 2 giant moons supporting the old god by the arms. But 2 years passed. In 1612, Galileo aimed his telescope at Saturn again to check on his little helpers. And that's when true horror struck him. The satellites had vanished. Saturn was absolutely round and alone. Galileo was in turmoil. He wrote to his colleagues, "Has Saturn, as befits the mythic god, devoured his own children?" The astronomer began to doubt his own sanity. Maybe the first observations were a mistake. Maybe the devil was playing tricks on him through these lenses. Galileo died never knowing the truth. Until the end of his days, he believed Saturn was simply mocking him. The solution came only 40 years later. The Dutch astronomer Christian Huygens, armed with a better telescope, realized what was happening. Saturn's ears hadn't gone anywhere, and they weren't moons. It was a ring, thin, flat, touching the planet nowhere. But why did it disappear for Galileo? The answer lies in the main mystery of the rings, which our brain refuses to perceive adequately. It is their thickness. We are used to seeing illustrations in textbooks where the rings look like massive solid discs, like a frisbee or a vinyl record. But this is the greatest optical illusion in space. Let's imagine the scale. The diameter of the main ring system is almost 300,000 kilometers. That's 3/4 of the distance from Earth to the Moon. If you decided to drive this distance in a car, it would take you 6 months of non-stop driving. Now, guess the thickness of this giant field. A kilometer? 100 meters? In most places, the thickness of Saturn's rings does not exceed 10 meters. 10 meters, that's the height of a 3-story house. It's less than the length of a semi-truck. If we shrank Saturn to the size of a soccer ball, the rings would be thinner than a human hair, thinner than a soap bubble. In fact, if you took a sheet of the finest tissue paper and cut out a model of the rings to scale, that sheet of paper would be too thick. You would have to split it into thousands of layers to keep the proportions. That is why Galileo lost them. Every 15 years, Saturn turns edge-on to Earth, and since the rings are incredibly thin, they simply vanish from sight. They become an invisible line. Galileo was looking straight at the edge of a razor blade hanging in space, but this fragility spawns another question. How can something so huge and simultaneously so thin exist? Gravity should have either torn them apart or rolled them into a ball. When the Voyager probe, and later Cassini, flew closer, the illusion of a solid disk shattered. We saw that the rings are not a solid road, they are a flow. Billions upon billions of pieces of ice, from tiny snowflakes to boulders the size of a bus or an apartment building, they fly shoulder to shoulder at breakneck speed, constantly colliding, breaking, and sticking together again. It is not a static picture, it is a turbulent, chaotic river. And the strangest thing about this river is that it looks too clean. The ice in Saturn's rings sparkles like fresh snow. It reflects almost all the light that falls on it. If the rings were ancient, like the solar system itself, 4.5 billion years old, they would be dark. Cosmic dust, micrometeorites, soot from distant stars, all this should have covered the ice with a layer of grime. Like city snow turns into black slush in the spring. But Saturn's rings are pristine white, and this fact led scientists to a conclusion that is frightening in its cruelty. The rings look new because they are new. By cosmic standards, they were born just yesterday, and for them to appear, someone had to die. When astronomers combined all the data received from Cassini, they came to a conclusion that seems impossible. The age of Saturn's rings is estimated at only 10, maybe 100 million years. It sounds like a huge number, but on a cosmic scale, it is a blink of an eye. It is yesterday. To help you understand the irony, when tyrannosaurs walked the Earth, when stegosaurs chewed ferns, Saturn was naked. If dinosaurs had telescopes, they would have seen a boring beige sphere in the sky without any decorations. You and I won the cosmic lottery. We live in that rare, short time when Saturn has rings, because they weren't always there, and they won't stay there forever. But where did they come from? Imagine an icy moon, about the size of our Mimas, 400 kilometers in diameter. For billions of years, it circled Saturn, a faithful companion. But gravity is a cruel mistress. The moon's orbit began to change, the spiral tightening. The moon drew closer and closer to the giant, and at some point, it crossed an invisible line. Astronomers call this the Roche limit. I call it the death line. As soon as the moon crossed this border, Something terrible began to happen to it. Saturn's gravity pulled the near side of the moon harder than the far side. The planet began to stretch. The ice cracked. A rumble grew in the depths, loud enough to burst eardrums if there had been an atmosphere. Look at your hands. Imagine you are holding a snowball. Now imagine someone pulls one part of it to the left and the other to the right. The snowball won't hold. In an instant, the moon simply exploded. It didn't collide with anything. It was torn apart from the inside by tidal forces. Billions of tons of ice, rock, and frozen gases spilled into orbit. At first, it was chaos. Giant chunks, entire mountain ranges tumbled in the void, colliding with each other, grinding themselves into dust. Gradually, centrifugal force pulled these remains into a flat disk. Large pieces pulverized the small ones ground down into powder. What we admire today looking at photos of Saturn is not an ornament. It is a crime scene. It is the entrails of a murdered moon smeared across orbit. We are looking at a giant ring-shaped graveyard. And this process of destruction hasn't stopped. It is happening right now. Cassini discovered another terrifying thing. The rings are dying. Saturn's gravity continues to pull this ice toward itself. Small particles lose speed and fall into the planet's atmosphere. This is called ring rain. Every second, 40 to 100 kilograms of icy water crash down onto Saturn. In half an hour, this rain could fill an Olympic swimming pool. Astronomers have calculated, at this rate, the rings will disappear completely. In 100, maybe 300 million years, Saturn will become a boring, lonely sphere again. Future civilizations that look at the sky won't see the beauty we see. They will see only an old, greedy planet that has finished its lunch. But if the rings are the ground-up remains of one unfortunate moon, what about the rest? Over 80 satellites circle Saturn. They survived. They are outside the death line. But that doesn't mean they are safe. Looking at them, we see scars of such force that it makes you uncomfortable. Some of them survived impacts that should have ground them to dust, but they refused to die. Among Saturn's 82 moons, there is one that elicits a nervous chuckle from any science fiction fan. Its name is Mimas. It is a small, icy world, less than 400 kilometers in diameter. But when the Voyager probe first sent us its photos in the 80s, NASA engineers froze. Staring back at them was the Death Star from Star Wars. The massive Herschel crater dominates an entire hemisphere of the satellite. It looks like a giant, unblinking cyclops eye. And there's a funny detail here. George Lucas came up with the design of his battle station 3 years before we saw Mimas. Space somehow copied Hollywood, but the reality of Mimas is far scarier than the movies. This crater is a scar from an impact so powerful it nearly destroyed this world. If the asteroid had been slightly larger or moving slightly faster, Mimas wouldn't be here today. We would just see another ring of debris. Imagine the scale. The crater takes up a third of the moon's diameter. If such an impact hit Earth, the crater would cover the entire Atlantic Ocean. From Canada to Europe, from Greenland to Africa, all of it would be one hole in the Earth's crust. The blow was so monstrous that shockwaves traveled through the entire body of the satellite. They focused on the opposite side of Mimas, tearing the landscape there to shreds. This moon literally cracked like an egg, but by some miracle, it didn't fall apart. It remained hanging in orbit, maimed, frozen, and dead. But Mimas isn't the only survivor in this story. A little further from Saturn drifts Tethys. This is a more serious world, 1,000 kilometers in size, and it bears a scar that makes the Grand Canyon on Earth look like a pathetic scratch. Astronomers named it Ithaca Chasma. It is a giant rift 100 kilometers wide and 4 deep, but the craziest part is its length. The canyon stretches for 2,000 kilometers, wrapping around almost 3/4 of the entire moon. Imagine a gorge that starts in Moscow and ends in London. Where did it come from? Nothing hit Tethys. The enemy was within. Billions of years ago, Tethys was likely liquid inside, an ocean of water under a thin crust of ice. But when Tethys began to cool, the water started turning to ice. And as we know from school physics, water expands when it freezes. This moon became too tight in its own skin. Internal pressure grew until the crust burst with a deafening crack. Tethys was torn apart from the inside by its own freezing heart. Ithaca Chasma is a stretch mark, a scar from when the planet tried to become bigger than its surface allowed. Today, Mamas and Tethys are silent monuments to violence. They are stones covered in ice where the temperature drops to minus 180 degrees. There is no wind, no sound, no movement, only eternal cold and craters staring into the void. It would seem that life is impossible in this part of space. This is the kingdom of dead matter. But just a few thousand kilometers from these icy corpses, there is a tiny world that breaks all the rules. It is smaller than them. It should be just as dead. But instead, it spits hot water in the face of death. Enceladus is a cosmic riddle the size of the United Kingdom. When we first looked at it, it seemed like the most innocent object in the system. It is the whitest, brightest object in the entire solar system. It reflects almost 100% of sunlight. It shines like freshly fallen snow. And logically, it should be a cold corpse. With its size, only 500 kilometers in diameter, it should have cooled and frozen to the core billions of years ago. But when Cassini flew by in 2005, the instruments went crazy. The magnetometer showed that Saturn's magnetic field bends around the south pole of Enceladus, as if something is pushing it, as if the moon itself is resisting the planet. NASA scientists made a risky decision. They ordered the probe to descend and fly directly over the South Pole. What they saw made them forget how to breathe. The south of Enceladus is slashed by 4 giant cracks. They were named tiger stripes, each 130 kilometers long. They are hot. Thermal imagers showed heat radiating from the depths. And then Cassini turned its cameras against the sun to look at the moon's silhouette, and it saw it. Fountains, dozens, hundreds of giant jets bursting from the cracks straight into open space. These weren't lava volcanoes. These were cryovolcanoes. Geysers of water, ice, and steam blasting to a height of hundreds of kilometers. The ejection speed is 2,000 kilometers per hour. This is a supersonic flow that overcomes the moon's weak gravity and flies away. Enceladus is so small it cannot hold its atmosphere. It simply exhales it into space. All this ice flying out of the geysers enters Saturn's orbit and forms the famous E-ring. Enceladus is literally dissolving itself to create the outermost and most ghostly ring of its master. But the real sensation happened later. Engineers reprogrammed Cassini for an insane maneuver. They directed the probe straight through these jets. At a speed of tens of thousands of kilometers per hour, the robot dived into a stream of icy shrapnel. It was like flying through a fire hose filled with buckshot. Cassini survived, and it did something incredible. It tasted Enceladus. Its cosmic dust analyzer caught particles from the geysers and broke them down into chemical elements. The verdict came instantly: salt and organics. The water in these geysers is salty, and salt in space means only one thing. Liquid water is in contact with a rocky bottom. This changed everything. Under the ice crust of Enceladus, 30 to 40 kilometers thick, splashes a global ocean, dark, salty, and warm. Saturn's gravity kneads Enceladus like a rubber ball, heating its core. At the bottom of this ocean, hydrothermal vents, black smokers, are likely active, exactly like those at the bottom of the Atlantic. On Earth, life thrives around such vents without needing the sun. Bacteria, crabs, worms live there. Think about it. 1.5 billion kilometers from the sun, in the icy void, there's a small ball with a hot heart. And right now, while you are listening to this, something might be swimming there, in the darkness of the subglacial ocean. It is the most probable place for alien life in the entire solar system. Not on Mars, but here. Enceladus gives us hope. It shows that water and heat can be anywhere. But Saturn is the king of contrasts. If Enceladus is a snow-white paradise with clean water, its neighbor is a toxic hell. A place that looks painfully familiar, but is actually an evil caricature of our home. If Enceladus is hope, then Titan is a haunting. It is Saturn's largest moon, It is so huge that it exceeds the planet Mercury in size. If Titan orbited the Sun instead of Saturn, we would call it a fully fledged planet. But when you look at it through a telescope, you don't see craters, mountains, or ice. You see a dense, impenetrable orange fog. Titan is the only moon in the solar system that has a substantial atmosphere. And this isn't just a thin haze like on Mars. Titan's atmosphere is 1.5 times denser than Earth's. It is a thick blanket of nitrogen and methane that suffocates the satellite, hiding its surface from prying eyes for billions of years. Scientists guessed for a long time. What's down there? An ocean, jungles, or just bare rock? To find out, humanity took an unprecedented step. In January 2005, Cassini dropped a passenger onto Titan, the European probe Huygens. It was the most distant landing in human history. Imagine the descent. Huygens looked like a flying saucer. It entered the orange sky at a speed of 20,000 kilometers per hour. The heat shield glowed red, saving the fragile electronics from incineration. When the parachutes opened, a long, agonizing descent began. For 2.5 hours, the probe fell through this poisonous smog, and it didn't fall in silence. There was a microphone on board. Huygens sent us an audio recording from the surface of another world, and it sounds eerie. It isn't the dead silence of the moon. It is the roar of the wind, the whistle of air flowing around the hull. We heard the breathing of an alien planet. It was the sound of a living, dynamic world. As the probe descended, cameras pierced the layers of haze. The fog began to clear, and outlines emerged on the screens at mission control that made scientists shudder. They saw Earth. They saw riverbeds winding through hills. They saw a coastline, islands, deltas where streams flowed into a vast, dark sea. It looked like the coast of Italy or California, shot from a plane on a cloudy day. For a second, it seemed we had found our home's twin. The probe landed with a soft splat in the mud. It didn't smash against rocks, but specifically splatted into something soft and wet, like wet sand or clay. It transmitted the first photo from the surface: rounded boulders, pebbles, a flat horizon line. Everything looked painfully familiar, and that made it unsettling. Because your brain says, this is a river, this is a stone, this is water, but the sensors scream something else entirely. The temperature outside is minus 179 degrees Celsius. The stones around are not stone. They are ice, frozen as hard as granite. The mud underfoot is not soil. It is hydrocarbon grit, and the rivers and seas the probe saw. Water does not flow in them. Water at this temperature is a mineral, hard as steel. It cannot flow. The liquid that created these shores, filled these seas, and is currently dripping from the skies of Titan is pure methane. Natural gas, the stuff we burn in our kitchen stoves. On Titan, it is so cold that gas turns into liquid. Titan is a distorted mirror of Earth. It has a weather cycle, rain, rivers, and seas, just like us. But instead of life-giving moisture, liquefied natural gas circulates there. We have arrived in a world where it rains gasoline. Let's take a walk on the surface of Titan. But be warned, it will be the weirdest walk of your life. The first thing you'll notice is the light. There is no day as we know it. The sky overhead is a thick, dark orange dome. The sun looks just like a very bright star from here, barely breaking through the haze. Noon on Titan resembles deep twilight on Earth in terms of brightness, eternal twilight. You are standing on the shore of Kraken Mare. This is Titan's largest body of liquid, larger than the Caspian Sea. But there are almost no waves. The liquid before you is oily, viscous. It is a mixture of liquid methane and ethane. If you throw a stone in there, it will splash with a dull, heavy sound, and the ripples will spread slowly, like in jelly. And beware of static electricity. The atmosphere here is so dry, and the surface so alien, that your every movement could cause a spark. If you move away from the poles, where the lakes are concentrated, you will enter a desert. Giant dunes, hundreds of meters high, stretch for thousands of kilometers, wrapping around the satellite's equator. They look like the Sahara Desert or Frank Herbert's Dune. But don't try to pick up this sand. It isn't quartz or rock. Titan's sand is organic. In the upper atmosphere, solar ultraviolet light breaks down methane molecules, turning them into complex hydrocarbon chains. Simply put, into plastic. This plastic snow has been falling on the surface for millions of years, sticking together into granules, and the wind drives them across the planet. The dunes of Titan are made of the same material as disposable tableware or styrofoam, just ground into dust. You are walking through a world buried in organic soot. But there is one feature on Titan that turns this hell into a dreamer's paradise. Gravity here is 7 times weaker than Earth's, almost like on the moon. But at the same time, the atmosphere is 4 times denser than ours. The air here is thick like syrup. This combination creates a unique physical phenomenon. If you strap artificial wings to your arms, ordinary ones made of cardboard and fabric, and push off hard with your legs, you will fly. You don't need a motor, you don't need magic. The strength of your own muscles is enough to soar over these methane rivers like a bird. You could do somersaults in the air, glide from dunes, and ascend into the orange sky just by flapping your arms. Titan is the only place in the solar system where a human can realize the myth of Icarus without dying. Well, barring the fact that without a spacesuit, you would instantly freeze and suffocate. But even from a bird's eye view, this world looks frightening. You will see rivers cutting canyons through ice. You will see deltas and floodplains. You will see clouds gathering into storm fronts. Titan copies Earth in everything but composition. It has its own cycle of matter. Methane evaporates from lakes, gathers into clouds, falls as rain, flows down rivers back into lakes. It works perfectly, but it is dead mechanics. It is as if someone built an exact replica of a living human, but filled the veins with oil instead of blood and used polymers instead of skin. And yet, the chaos of Titan seems understandable. Weather is weather. But if we rise from the surface of this moon and look at Saturn itself, at its north pole, we will see something that defies all weather logic. There, in the center of a giant storm, nature has drawn a perfect geometric figure. The lines are so straight, as if they were drawn by a cosmic architect's ruler. We return to Saturn itself, to the giant that holds this entire retinue of moons with its gravity. And if you look at its north pole, you will see a thing that shouldn't exist in nature. Nature hates right angles. Look at hurricanes on Earth. They are spirals. Look at planets. They are spheres. Look at orbits. They are ellipses. Liquids and gases, when rotating, always strive to create a circle. But at Saturn's north pole, a storm rages in the shape of a perfect hexagon. This is not an optical illusion. It is a giant nut screwed onto the top of the planet. It has 6 even sides, 6 sharp corners, and it rotates. To give you a sense of the scale of this geometric miracle, each side of the hexagon is larger than the diameter of Earth. Inside this figure, you could freely fit 4 of our planets. In the center of this structure lies the eye of the storm, a vortex 50 times larger than any earthly hurricane. And along the edges, forming these straight walls, winds blow at a speed of 320 kilometers per hour. Scientists racked their brains for decades. How is this possible? We tried to model it in laboratories, spinning tanks of water. It turned out that at certain speeds, liquid can indeed form geometric figures due to wave resonance. But knowing the physics of the process is one thing. Seeing it with your own eyes is another. It looks artificial, as if some ancient architect left their signature on the pole of the gas giant. This structure is incredibly stable. Voyager saw it in the 80s. Cassini filmed it for 13 years straight. Seasons on Saturn change. The hexagon changes color from blue to gold, but its shape remains unshakable. But Saturn terrifies not only with its appearance, it terrifies with its voice. Cassini recorded the planet's radio emissions, the so-called Saturnian kilometric radiation, and when scientists translated these radio waves into the sound range accessible to the human ear, they felt uneasy. Saturn is not silent, it howls. It sounds like a soundtrack to a horror movie from the 50s, an eerie, high-pitched whistle turning into a screech, like the screams of ghosts or the sound of wind in an abandoned house. This sound is born in the place where the planet's magnetic field collides with particles of the solar wind. It is the song of the auroras that never cease on Saturn. Remember we said space is silence? Near Saturn, that isn't true. If you could hear radio waves, you would go deaf from this scream. And so, looking at this hexagon and listening to this howl, you understand one simple thing. Saturn is not a place for us. It is a planet without a surface. There is nowhere to land. If you start falling, you will sink through layers of ammonia clouds, through hydrogen and helium. The pressure will rise until the gas becomes thick as syrup, and then hot as lava. Deep down, where the pressure is millions of times higher than Earth's, hydrogen ceases to be a gas. It turns into metal, a liquid metallic ocean that conducts electricity and generates that monstrous magnetic field. Saturn is not a hospitable world. It is a giant soulless engine operating by laws we are only beginning to understand. It is beautiful with the beauty of a nuclear explosion or a tsunami. From afar, you can't take your eyes off it. Up close, certain death. And it was into this monster that we had to send our little robot. The year 2017 arrived. Cassini's fuel was running out. Leaving an uncontrollable probe drifting in orbit was impossible. The risk of collision with Enceladus was too great. The team made a decision. Cassini must die so that the secrets of Saturn remain untouched, but it must go out beautifully. Operation Grand Finale began. The Grand Finale is not just a beautiful name. It was an act of absolute engineering audacity. NASA decided to send Cassini where no spacecraft had dared to venture, into the narrow gap between the planet and its rings. The width of this corridor is only 2,000 kilometers. On one side, the furious atmosphere of the gas giant. On the other, a wall of ice blocks flying at the speed of a bullet. Flying there is like threading a needle at a speed of 120,000 kilometers per hour. And doing it blindfolded, controlling the hand with a delay of an hour and a half. Cassini did it 22 times. 22 times it dived into this death zone, passing so low over Saturn's clouds that if there were air, we would have heard a whistle. It created a gravitational map. It learned the exact length of a day on Saturn. It sent photos of the rings from a bottom-up angle that makes your head spin. But the fuel was running low. Every maneuver brought the inevitable closer. On September 15, 2017, the trajectory closed. The final orbit. No paths for retreat. In that moment, Cassini ceased to be just a machine. For thousands of people who followed it, it became a friend. It was our eyes there, in the dark, for 13 whole years. An entire generation of astronomers grew up on its photos. Children born on the day of its launch were already finishing school by the moment of its death. It showed us that the solar system is not a dry set of diagrams. It is a place full of drama, violence, and incredible beauty. In its final seconds, it fought. Thrusters roared, trying to hold the antenna steady. It wasn't just falling, it was working. Until the very moment of disintegration, it transmitted data on the atmosphere's composition. And, in a sense, Cassini didn't die. Its atoms, its molecules, the very aluminum, silicon, and gold it was made of, all of it scattered in the clouds of Saturn. It became part of the planet it loved most. Now, when you look at Saturn through a telescope, you are also looking at Cassini's grave. It is there, forever fused with winds blowing at the speed of sound. What did we get in return for this sacrifice? We gained knowledge. We learned that even in the icy abyss, there can be liquid water. We learned that rings are a temporary phenomenon, and we are lucky to see them. We learned that Earth has an evil twin where it rains gasoline. But most importantly, we learned our place. Saturn is indifferent to us. It doesn't care if we look at it or not. It spins in the void, grinding its moons, creating its storms, keeping its secrets. It is vast, cold, and beautiful. But we, those small, fragile creatures from the third planet from the sun, we managed to reach out and touch it. We created something that flew 1.5 billion kilometers, dived into a geyser, raced through rings, and dissolved in the sky of a giant. And as long as we are capable of such curiosity, as long as we are capable of sending messengers into the void simply to find out what's there, we have a future. Saturn's rings hide many secrets, but one we now know for sure: the universe is much more complex, terrifying and beautiful than we could have imagined, and it is waiting. Thank you, Cassini. End of transmission.